Everyone, this video we will talk about average rate of change. So before jumping into what it means, let's break it down into the three words it contains: change, rate, and average. So what is change mathematically? The most, let's say, a general definition would be change indicates final state minus initial state. So it's some sort of a difference between what is and what was, or what will be and what is. So it's a final state minus initial state. And you can talk about change in speed, change in distance, change in time, any such quantity. So fundamentally, change is some sort of subtraction between two quantities. Okay, so like A minus B. So the mathematically coding of change would be a subtraction. The next word here is average. Average, what we do is we take what we just defined, which is change, and we measure this change over a period. For example, let's say if I have to take average of numbers 5, 10, 7, 6, 3, so I add them up and I divide by the number of the things. So average is 5 plus 10 so on divided by the 5 things. That's one way that you are familiar talking about averages. Okay, but here what we are going to learn is that there's another definition of average, or another definition of average in terms of rate. So what this rate does is it looks at change in one quantity divided by change in some other quantity. So the rate, what it tells you is how something is changing with respect to something else. So for example, speed tells you how is position changing with respect to time, and so on. So that would be the rate. Now the average rate would be it's going to be something like average of numbers, but it's going to incorporate change in a slightly different way. So we're going to look at examples of those as we go on. Now one important thing that we always talk about when we say change is that there are three things that can happen, right? So in terms of change, either there's a simple case of no change, or you have the case that something increases, and you have the third case in which something decreases. So for example, you can pause the video here and try and identify on this graph here when the function has no change, when it is increasing, and when it is decreasing, roughly. Okay, hopefully you looked at that, and we can say that in this period of January here, there's roughly no change, right? Then between January and say mid of February, it increases. And to generalize again, we can say the period of March to early April is again a period of no change, and then there's a sharp increase. Let's say all of this is increase, and then we have a period of decrease, and then we have a period of increase again. Okay, so basically any which way. So if you have 2 points, there are 3 ways in which you can if you have to make 2 points, or let's say you have to pick a second point given 1 point, you can either pick it parallel, which would be the no change. You can pick it higher, which would be increasing, or you can pick it to be lower, which is decreasing. Okay. And this idea is encapsulated as change in input over change in output. Meaning, so for example, if I have something like that, when the input is 1, the output was 2. When the input is 3, the output was, say, 2.5. Now in this period, my change in input is the change in x value, which is 3 minus 1, which is 2. And for that corresponding change in input, my change in output was 2.5 minus 2, which is 0.5, in which the output 2.5 corresponds to the input 3 and the output 2 corresponds to the input 1. Then in this case, we say the rate is the change in output over the change in input, which is 0.5 over 2, which is 0.25. So for example, here between x1 and x2, it is constant, decreases and increases. So the average is going to look like, if this is a function f of x, then in general, if my input is x1, this output by our function notation is f of x1 and this is f of x2. So the rate is going to be f of x2 minus f of x1 over x2 minus x1. And then you will see that in the case of linear models, this rate corresponds exactly to slope of the line. Let's look at an example for clarity. You're given a function x minus 3 whole squared. Find the net change and the average rate of change. So for net change, all you have to do is find the output. So at 1, the output is 4, and at 3, the output is 0. So the net change is 4. Sorry, the net change is final minus initial, it's negative 4. And the average rate of change is this change which happened over a change of input of 2. So it's negative 4 over 2, which means it's negative 2. Similarly, from when x is 4, this is 4 minus 3 squared, which is 1. 7 minus 3 squared, which is 16. So the net change this time is positive because it's 16 minus 1 is 15. And the average rate of change is 15 over 3, which is 5. So for the same function between 1 and 3, the net change is negative, the average rate of change is negative, meaning it is decreasing. And here it is increasing. Okay. More clarification on this in the next discussion. So it says, when is this average rate of change positive and when is it negative? Let's plot this function. X minus 3 squared, is a parabola centered at 3. So that's what it looks like. Okay. Now from 1 to 3, what is happening to the function? From 1 to 3, it is decreasing. And from 4 to 7, it is increasing. Now when a function is decreasing, the rate of change, this quantity, this was going to be negative, because if it's decreasing, then the final state is less than the initial state. So f of x2 is smaller than f of x1. And similarly, if it's increasing, then f of x2 is larger than f of x1, so the change is positive. So we can say that if the average rate of change is positive, then it is increasing, else it is decreasing. However, this is not entirely true, because it may be the case that, for example, here, this is going to come out to be negative, but the function is not decreasing always, right, between x1 and x2. It kind of decreases and then increases. So this result here is to be taken with like sort of terms and conditions applied. But the idea that I want you to take away from this is, looking at the average rate of change can tell us about increasing or decreasing nature of a function. Okay, now a more general question says, take x plus a to be this function for any number a. What is the rate of change between x equals 10 and x equals 10 plus h for some number h? So let's take my initial. The initial position is x equals 10, and then the output is 10 plus a. My final in terms of input is 10 plus h. In terms of output is what happens when I plug in this 10 plus h, which is 10 plus h plus a. So my change in output, that is f of 10 plus h minus f of 10, and that is 10 plus h plus a minus 10 minus a, and that is h. And my change in input is 10 plus h minus 10, which is also h. So the rate, which is given by change in output over change in input, is h over h, which is 1. Right, so the rate of change is 1, it is constant. So although we have these variables or varying constants, varying parameters a and h, the rate is constant. And this sort of makes sense, because what does x plus a look like? X plus a looks like these blue lines, one of these lines, for different values of a. And if you look at the change at any of them, the change is always 1 by 1, meaning you get a rise of 1 for a run of 1, and which is essentially just encoding the fact that the slope is 1 for any value of a. We discuss more on this in the following videos, where we talk about linear models and straight lines and slopes as rate of change. Okay, that's it for this video.